Okay, this is problem 15 from homework number 1, and I just wrote the question down here. It says, a spherical wave with a wavelength of 2 meters is emitted from the origin. At one instant in time, the phase at radius is equal to 4 meters is pi radians. At that instant, what is the phase at the radius equals 3.5 meters and when the radius is equal to 4.5 meters? So to start this problem, I like to write down what we are given. So we can call that known. So we know that at this instant in time, the wavelength is 2 meters. The radius is 4 meters. And the phase, when the radius is equal to 4 meters, is pi. Then I like to make a list of what we're looking for. So in this case, we are looking for the phase when the radius is equal to 4.5 meters and when the radius is equal to 3.5 meters. Now that we have all that written out, it's nice to find an equation that can sort of tie all of that together. And I found this equation, which is an equation for the phase difference for 2 points that are on the same wave. And since this says just a spherical wave, you can assume that the points are on the same wave. So that says that the phase difference is equal to 2 pi times the change in x over the wavelength. And in this situation, x is equal to r. So I'm going to write that again, but instead of an x here, I'm going to put an r in, so it makes sense with our variables. So now it's pretty much just plug and chug. I'm going to start with the phase at 4.5. So to write that out, I'm going to say phase change is equal to 2 pi times 4.5 meters, which is what we want, minus 4 meters, which is what we have, divided by the wavelength, which was given as 2 meters. And this is equal to pi over 2. Because this would give you 0.5, and the 2's would cancel, so it would give you 0.5 pi, which is the same as pi over 2. And that's in radians, because the meters cancel. Now, since both of the phases that we want are changed by 0.5, you can use this change for both of them. So the pi for r is equal to 4.5 will be the phase of r at 4 meters plus pi over 2, and the phase when r is equal to 3.5 meters will be the phase when r is equal to 4 minus pi over 2. Now I'm going to put in the numbers, and you get that pi plus pi over 2 and pi minus pi over 2. And so for this one you get 3 pi over 2, and this one is just pi over 2. So in the end, your phase where r is equal to 4.5 meters is 3 pi over 2 radians. And the phase when r is equal to 3.5 meters is pi over 2 radians. And that's it. I hope that was helpful.